First, for the transverse wave. Transverse waves are those waves in which direction of vibration of particle is perpendicular to the direction of motion of wave. It means if the particle of the medium oscillating up and down, but as a result energy is propagating in direction perpendicular to its motion, means here like we can see energy is transmitting from here to here, means this is the direction of propagation and this is the direction of vibration up and down. So this both are 90 degree to each other. So this type of wave form the longitudinal wave. Transverse. This type of wave form transverse wave. Example of the transverse wave, suppose in the still water, if you throw a stone or a pebble, then it will start forming the ripples like this. This is example of the transverse wave. In transverse wave, we have crest and trough. Positive half of the cycle, this is the negative half of the wave, and this complete length of the wave, that is called wavelength, and the number of waves passing through a given point for once in 1 second, that is called frequency of the wave. That is called frequency of the wave, where k, this is a propagation constant and its value is k value is 2 pi by lambda, where omega, this is the angular frequency, and value of omega is 2 pi by t. This is the value of omega. Next is, for the formation or the propagation of a transverse wave through a medium must possess few properties. For the propagation and formation of a wave, transverse wave, especially in a medium must possess 4 properties, like first, elasticity. Medium must have elasticity so that particles that are vibrating about the mean position come back to the mean position. Second, inertia, so that particle can store energy and overshoot the mean position. Third is minimum friction, so that wave can propagate through it without getting decaying before reaching the target. And fourth is uniform density of the medium. As we know that mechanical wave, transverse wave is a mechanical wave, they require medium for their propagation. So the medium must have uniform density, so they can propagate properly through the medium. So these 4 properties are essential for a medium so that formation and the propagation of the transverse wave can occur through them. Next is longitudinal wave. Longitudinal waves. In longitudinal waves, the direction of vibration of particles, vibration or oscillation of particles is along the direction of propagation of wave. It means what? That if a wave is propagating in this direction and particles are also vibrating in this direction, like if I have a spring, if I make it to oscillate, it will oscillate to and fro like this. It will oscillate like this. Oscillate like this. And vibration propagation is also in this direction. So, longitudinal wave have compression and rear friction. Compression is the region in which the particle come quite close to each other, and rear friction is the region where the particle lie away from each other, like this. Sound wave is the best example of the longitudinal wave that you also have to study about the sound wave in class 9th. And for the transverse wave, the example is light. So this was about the longitudinal and the